Yeah, so I do not know what you missed, but I want to speak with you about the essential role of livestock. Actually, when you look at the agricultural policy in Europe, there is a debate, there is a dispute about whether livestock should be a part of the European agri and food system in the future or not, especially because of the climate impact of livestock production. I saw one of the questions about the presentation of Tanya. I see that livestock production is being in the eco schemes of some countries. Does that mean that livestock farmers go into crop farming? There is that tendency of a transition from animal-based proteins to plant-based proteins, etc. But the question is, if that's the way forward, is livestock fading away, or is it essential? I think these are the two sides of the coin. It's about the footprint on the one hand. We had in 2007 the FAO report Livestock Long Shadow. But it's also about circularity and the role of livestock in circularity. In 2017, the FAO came with tackling climate change through livestock. Actually, these are two opposite opinions, opposite views on the role of livestock in the future. And we have to find a balance. On the one hand, the footprint reduction, but on the other hand, do not forget that in a circularity, land crops, livestock manure, land crops, livestock manure, livestock is as an important connecting point as the soil is. Food within planetary boundaries, how to achieve. Actually, this is a long story, but to keep it short, during the last century, in the Green Revolution, we were mainly focused on food security with standard top resources, production oriented, with high production efficiency, with based on the good resources, producing commodities for the food security all across the world. But more and more we came to the insight that it is the planetary boundaries that is limiting the perspectives for further development of the agriculture. And actually it's not only about food security, but it is also about resource sufficiency. And also here it's about the balancing the two. When we speak about resource sufficiency, I think that the most clear solution is to look for circularity, to use the resources that we are using, reuse the resources that we are using in circularity. That also comes along with zero waste, so that we're not wasting and we not have the emissions related to the waste. Actually, all the emissions that we speak about, whether it's greenhouse gas emissions or whether it's environmental pressure on water quality, soil quality, air quality, is all related to the biomass that we are not using and that we are leaking to the environment. So moving towards circular agronomics is really a key essential, and you see that also in the European agricultural policy as a way forward, a pathway forward. But in a circularity in the agri-ecosystems, animals are essential. Soil is the basis, but livestock also connects. It comes to the feed of the livestock. Can we use circular resources to feed the livestock? And by that saving the land use in a way that it's beneficial for the biodiversity. And on the other hand, can we fertilize the crops with circular resources? And the manure is such a plentiful and nutritious full resource for fertilization, with also the benefit of carbon sequestration. But then circularity and the role of livestock in circularity requires a different livestock system than we had in the past. It's not a livestock system based on the standard feed crops and maximum production of that, but it is based on feed sufficiency. And here we have the challenge for the science and for the research, the power of broader thinking, not only the standard feed crops and the food processing co-products and ingredients as basis for the animal feeding, but also refined roughage, food crop leftovers on the one hand side, food leftovers, the food waste, and the swill on the other hand side, of even more broader thinking when the cropping system moves into more mixed cropping. We can have catch crops that can be feed crops, and what to think about the food leftovers and the swill to produce insects and using the insects for the animal feed, and what about the 70% of the earth where the primary production is with seaweeds. Can we use seaweeds for animal feed? So this is all. These are all the options for broadening the feed sufficiency. The other side is the circularity in manure-based fertilization. That's the power of reverse thinking. I think all across Europe, where we have intensive livestock farming, we see that manure is a waste. It's been collected as a slurry, as a sludge, and we treat it sometimes. But it's a high source for emissions, greenhouse gas emissions, nitrogen emissions, etc. And rethinking is to have a look not as a waste to this material, but as a resource, and to valorize the manure in a good way, to already collect it in a good way, urine and feces are separated, preserve it in that the high quality is still standing there, separate it in good minerals, good organic material, reusable water, etc. Co-products. But then we need a livestock that is capable of playing that role in circular food security. And for that, we need another type of research in livestock as well, not monodisciplinary, very focused on animal breed, animal feed, animal welfare, etc., but more integrated, inclusive and interdisciplinary research, including the context of the livestock farming. It's not just the livestock farming as such and how to mitigate the adverse effects, but it's more integrated, inclusive, and context-wise. I'm very happy that the Animal Task Force, and I see Frank Amara is participating in this webinar as well, together with Plans for the Future, really come up with a vision on going beyond the feed versus food debate and looking for the ways how crops and animals together are there to address food and nutrition security. But that requires also that Feed for Future means that we have to look on the integrative way of the livestock sector and the cropping sector and the food sector, etc., etc. The same holds for breed for food. It's not just the productivity of the animal breeds, but it's also the capability, the adaptability of animal breeds to play that role in the circular system. And it's about the merger with the technical sciences on the precision farming technologies that's required when you want to keep the livestock in such a role that it fits in connected circularity. But don't forget the social sciences, because the social concerns are really dominating the question whether or not there is a role for livestock in the future food system in Europe. And that brings me also to this point. Yeah, we have a very classical way of thinking about yeah, the food transition, how food consumption can direct the food production in a more sustainable way. Life cycle analysis is part of that, but life cycle analysis doesn't address the circularity in its full capacity. It actually addresses all kind of commodities as single production chains, and the footprint as a kind of given quantity rather than a quality that can be played with when you have a good management practice. So this kind of things gives you the idea that livestock is the big carbon footprinter and the big water footprinter. And avoiding meat and dairy is the single biggest way to reduce your impact on Earth. But when you have a more system way of looking at the environmental impact, the ecological impact, these are the models that are produced in Wageningen by the group of Imke de Boer, you see that circularity can really lead to sustainability by a balanced optimization of the food system. In this graph, you see the amount of resources or land needed to produce a certain amount of food. So the lower, the better. The red is our existing system with limited connected circularity in the agri system, and there you see that the optimum is when we have 25% animal-based proteins and 75% plant-based proteins. So this is the argumentation that we are already at 50 or 70% animal-based proteins in our food producing system, that reducing the animal-based proteins is good for the environment, at least to a certain point, until that we reach the in the food transition the red star. When we going more to one-sided plant-based protein production, then we're losing the win, and we need more land and resources to produce our proteins. But what if we really are connecting the food system, interconnecting the food system with connected circularity? That's the green line. And then first of all, you see that the green star is at the half of the resources or land use than the red star. So that is the win. That's a bigger win than we can get. That's the win that we need to the targets of 2050 to have a food production within the planetary boundaries. But you also see that the green star is at more or less half animal-based protein and plant-based protein balance. So yeah, this gives another picture of the role of livestock. But in the green star, you have another livestock system than in the red star that we have now. So there is a transition needed. Here you see that this type of circularity in the system really helps you to move forward. This is the greenhouse gas emissions in the Netherlands in 1990 and 2070 is a reduction, and we have of course a climate action plan that foresees with standard mitigation options a further reduction to 2050, but not a net zero. The net zero only comes in the picture when we have a full circularity. So here I think is the role for science as well. After the implementation of the mitigation options that we have to meet intermediate targets for 2030, we really need to explore the potential for more systemic net zero options in the full system. And yeah, it addresses also the study of Oxford, where it has been been envisaged. This is a kind of exploration that the carbon cycling in the biosphere, where cattle, where livestock can play a very important role in, is can be much more closed and can be isolated from the carbon cycle in the from the biosphere with the atmosphere. So we can keep the carbon in our biosphere system, where the agriculture is the main part of. The same holds for the circularity of water. If we are not using resources that we using so much that in the final end we waste more than we are producing, than we are keeping, that we are not bringing back in the system, then we have the emissions, then we have the water losses. But when we close the cycles, when we close the loops, then we really can address the climate change and the water scarcity as big issues. With thanks to the Livestock, and I also want to thank you for your attention. Hopefully it opens your ideas also about the role of livestock in the European agriculture policy and the way of eco-scheming the CAP.
Thank you very much, Martin.